Hey, what's going on, students? So I wanted to show you another method to graphing a quadratic equation, a quadratic function. So let me get set up here, x, y. Still want to use a table, but this method, it makes you start with the vertex finder, and it wants you to put it in the middle of the table and then work each direction. Well, that's okay, and that works, but if I completely try something different, I think we can get the same result and maybe learn a little bit of extra along the way. So let's still start with the vertex finder, but let's go ahead and put it right here in the first spot, in the first row for the x value. So remember, the vertex finder is negative b over 2a. This is the same example from your notes. So in the notes, we may have done it differently, but this is kind of a second way, okay? Another option, all right? So negative b over 2a would be a negative 6, so a positive 6, over 2 times 1, which is 2. Okay, 6 divided by 2 is 3. Okay, now instead of going in the middle and going each direction, how about we just start with 3 and then go to the right? So 4, 5, 6. We could do 7, but I don't think it's going to fit, so we'll just stop right there. We only need to do a couple of coordinate points to the right. So let's start with x equals 3. Where does x equal 3? Right here. So one thing you can draw right away is you can draw your axis of symmetry. I have that ready. Let me slide that up right here. Boom. Okay, so there's your axis of symmetry. That means everything on the right is going to equal everything on the left. So that's why I'm just going to go to the right. So I'm going to do 3, 4, 5, and 6. And then I'm going to copy everything on the right to the left. So this is a bit more smooth, I think. You start at the top of the table, you go to the right, and then everything on the right you copy to the left. But here you would plug in the value, so we do 3 squared minus 6 times 3, there we go, plus 4. Sometimes it's easy just to copy a blank equation and then dump the numbers in. So copy, minus 6, bracket, plus 4. Bracket squared minus 6, bracket plus 4, dump in the 4, dump in the 5, dump in the 6, and here we go. Some other things that you can do before we start graphing too many coordinate points is always look for the y-intercept. So remember this plus 4, that's the y-intercept. So 0 and 4. So I got a funny feeling that's going to be one of our coordinate points. So that's 0 and 4. Okay. Anyway, let's go ahead and graph the vertex. This is the vertex finder. So we plug in a 3. I believe we have a 3 squared minus 6 times 3 plus a 4. I don't have my calculator ready. I'm too slow on this one. I'm so sorry. Here we go. I just did this example too, so you'd think I'd have the numbers memorized, but I don't. Okay, we get a negative 5. There we go. Now it's coming back to me. There we go. So 3, negative 5. 3, negative 5 is right there. There we go. So there's 3, negative 5, our vertex. We plug in a 4. 4 squared minus 6 times 4 plus 4 is a negative 4. Okay, so we have 4, negative 4. 4, negative 4 is right there. So there's 4, negative 4. Now, as soon as you can keep going, or you can go ahead and use symmetry. So if 4, negative 4 is 1 unit to the right, its copy would be 1 unit to the left from the axis of symmetry. So 2 and negative 4 is also going to be a coordinate point. Bracket 2, negative 4. Okay, gotcha. So there you go. So if you're 1 unit to the right, you would have a copy 1 unit to the left from the axis of symmetry. Here we go. We plug in a 5. I think this gives me a negative 2, but let me double check. I've done this problem so many times. Like I said, it'd be nice if I could remember this, but it's also good to plug things back in and double check. You get a negative 1. So 5 and negative 1 is right here. 1, 2, 1, 2. There we go. There is the line of symmetry. Using the line of symmetry, the axis of symmetry, 2 units away, copy and paste, 2 units away. So one of our coordinate points is going to be 5 and negative 1. And it's carbon copy, not really carbon copy, it's mirrored image. There we go. That's the proper term. Would be 1 and negative 1. And then, if we plug in a 6, let's see here. 1, 2, 3, 1, 2, 3. I think we might land here. Let's double check. We plug in a 6. I hope we get a 4. Here we go. 6 squared minus 6 times 6 plus 4 is indeed 4. 6 squared minus 6 times 6 cancels, plus 4 is 4. So there we go. 6 and 4, which symmetry helped me figure out, but also with the table. So there we go. We got all of the corner points. Now I've got the pre-made parabola because they're kind of hard to sketch. They're hard to draw, so I got one pre-made. I'm going to go and drop it right in there, and boom, there we go. Not too bad. Cool. But again, students, notice the symmetry. The corner points at the same height are going to have the same y value. So these corner points up here both have a 4 for the y value because they're at the same height. These ones are going to have the same y value because they're at the same height. These are going to have the same y value because they're at the same height. So using symmetry is actually pretty slick in this method. So the other method, you put the, in the other method, you would put the vertex finder in the middle, and then you'd go both directions. With this method, you just go one direction, and then you copy and paste to the other side. So I don't know. To me, it's about the same number of steps. I think this one's a bit more smooth because you just go one direction, and then you also use the idea of just symmetry to copy to the other side, which is a pretty good technique to use. So that's another way to graph a quadratic equation by hand. Start with the vertex finder, go to the right, and then copy and paste over the axis of symmetry to the other side. All right, cool. We'll see you in class.